welcome back to another video of H&H Express model nscale trains. In the last video I showed you the start of how I put power on the track. In this video I'm going to show you how the schematic is and show you as well the final result of that build. And later on, and that may be another video, I'm going to talk about the programming of the Arduino so we can really use it to put power on the track and have trains running. So let me dive into it and let's go over to the computer.
So here we are back at the computer, and here is an overview of all the components which we are going to use. So here is the Arduino Mega. On top of that we have a 2x16 LCD display. It will show the status of what is going on. We have here the PCA 9685. This is a servo controller, but you can control the speed by using PWM pulses on the yellow pins. We have the PCF 8574 I/O controller. This I/O controller you can use as inputs and outputs. I'm going to use it as outputs. We have the motor driver. It has two outputs. So on the right hand side and on the left hand side. We have some control pins at the bottom. And we have a 5 volt, a ground and a 12 volt. We are going to use current sensors. These current sensors which I use are rated up to 5 amps. And we have on top of that we have the track section. So this is power section MainTrack 01 and this is power section MainTrack 02. So let's see how the wiring is. First we're gonna start with the ground wiring and then with the 5 volt. So as you can see, these are all connected. Every component uses 5 volt and is connected to the ground. You need to be careful with the PCA 9685 because the wiring is bottom is ground here, and VCC, that's the one which we are going to use, is the second pin from the top. And then of course we're going to use feed in the 5 volt over here on the motor driver, and the current sensors also need 5 volt to operate. Next what we're going to do is we're going to connect the I2C bus. The yellow line is the clock and the orange line is the data line. So all the components which I'm going to use, so the LCD display, the speed controller and the I/O controller, they are all communicating over the I2C instead of separate pins on the Arduino. So now I'm using only 2 pins, pin 21 for the clock and pin 20 for the data. Next we're gonna wire up the current sensors. So in this case we have 2 current sensors that will detect if there is a train on the track when there is power on the track. And we will connect them because they are analog signals to the analog input outputs of the Arduino. So we are going to connect power section 1 to A0 and power section 2 to A1. And you will see later when I show you the original configuration wiring of my motor section that we're going to use almost all analog pins of the Arduino. So next we're going to connect with the same coloring the PWM pins on the motor driver to control the speed. So we connect that to pin 0 and pin 1. So the right hand side is pin 0 and the left hand side is pin 1 on the PCA controller. In the original wiring I'm going to use multiple motor drivers. I have in total 11 mounted. So you can imagine that I need to use multiple speed controllers or servo controllers in my layout. So next we're gonna wire up all the control pins, and all these connections, so 2 connections for the right hand side and 2 connections for the left hand side. With the PCF 8574 I can control 2 motor drivers or 4 tracks, because you need to use both pins. First you need to put power on the track, that is to put 1 pin high, but you can also do a reverse or a forward, and that is done in the program to have the train remove in a forward or a reverse section on the track. So next we're gonna wire up the track itself. So first power section 1, and you see that the connection goes through the current sensor and then to the track itself, and this current sensor detects if there is current flowing, and then it will send a signal to the corresponding pin on the Arduino, which then detects that there is a train in this track, which means that the track before that will not have a train or will not have power, so that the trains cannot collide together. So next we will wire up the other power section. So here you can see as well that the power goes through the current sensor to detect that there is a train. So if there would be a train in power section 2, then it's not allowed to have a train in power section 1. So that is called block detection as well. You can do that on various methods. You can either use optical signals that a train is detected. I'm going to use a current sensor to detect a train. What I will need to do on each coaches, I will need to put resistors on the wheels to make sure that there is a current flowing, and that the current sensor can detect that there is power on that, when there is power on the track, that there is a train on the track as well. At last, we will put the 12 volt on the motor driver, so that is this line here. And one thing which you will need to do, and that is why I put a big arrow here, you will need to remove this jumper on the motor driver. If you do not remove that jumper, you cannot feed 5 volt on this pin, because with this jumper it will transcode the 12 volt via the voltage regulator to 5 volt logic for this motor driver to function. But since you can put more than 12 volt on this pin, you are advised to remove this jumper so that you can supply your own 5 volts for that logic. Otherwise you will blow up this voltage regulator, because it's not rated to be used higher than 12 volt on that voltage rack. So that is how the schematic is for 2 tracks. And I have 14 power sections on the main track, so I have wired this up 7 times. So I use 14 current sensors, I use 7 motor drivers, I use 7 I/O controllers, and I'm using 2 speed controllers at minimum, because I can use all 16 pins, but that's not what I'm gonna do. I don't have long enough cables to do that, but using multiple speed controllers would not be an issue. So this is how the wiring is, and let me show you how the wiring is now on the board itself. So here we have the completed board. As you can see, this section has not been finished yet. We have the motor drivers, at least it's finished for the main track. So we have the motor drivers, we have the current sensors, over here at the top. We have the IOs, which are hidden underneath the cables. Then we have the servo controllers over here, the Arduino, and an LCD display, and I enlarged it a little bit on the screen. And what you can see is there is a test program running, and the test program turns each track on, and you see FWD, that means forward motion. Then we have reverse. Then we have a stop, so that track is finished. Then it goes up to the next track, forward, reverse. And what it shows here on the display is which IO it is using. So address 20, this is IO board 0, pin 6. And here it says for the servo controller address 40, IO board 1, pin 4. So that way I can easily identify if there is a problem, where the problem lies. On the screen itself, you see that there is also mentioned the track, if it's going reverse or forward or no power, and there is a current value with it. Those are the current detected when the LED is lit or not lit, or if there is no power to it. So I still need to tweak that, but that will be a progress when there is a train running. Here on the top you also see a track. I did some testing on the initial first track to see how that went. So next is all the programming for the Arduino and JMRI, that I can power on a track and power off a track, and that will be done in later videos. So if you want to see those videos, please consider to subscribe to my channel. Hit the bell icon to get notified when further videos are uploaded, and I will see you in a next video. Thank you and goodbye.